Hello everyone, my name is Jemna, and today I would like to talk about springback and springback compensation, which is an important phenomenon in mechanical engineering and in material science. So, in order to understand what is springback, first let's look at the definition. Springback is the measure of elastic recovery after removing the loads from sheet metals after the bending process is finished. So it happens in sheet metals, so it is used in metal forming to ensure that the final shape of the metal that we assume is the same as the shape we desire. So we check if the final shape of our metal is the same after the bending is finished. So let's look at the figure here. So this is before and after. What we mean by before is actually after the bending. So when we do the bending process, this is the shape of the sheet metal. And after the springback occurs, we see a little elastic recovery from the sheet metal. So the metal workpiece is removed from the forming tool. Then the elastic deformation is released, so elastic recovery occurs. The plastic deformation still remains because, as you see, this is not a flat sheet metal right now. It is a bended one. And after the elastic recovery is happening, the workpiece will spring back. So let's look at the engineering stress and engineering strain graph to understand it better. As you see, as you know, a material has both elastic deformation and plastic deformation. And after the plastic deformation, even if it is a state, even if it is in a state where it cannot go back to its original shape, there is still some elastic recovery. So we see that this elastic recovery can be seen as springback. So springback has a critical role where the bend radius to thickness ratio is high, such as in automotive body parts and structural members. You will see that more in our examples. I will explain it more. So how bend angle and radius changes. As you see, this is the final bend angle, and this is the initial bend angle. The final bend angle is smaller compared to the initial one. And the final bend radius is larger compared to the initial one. So the final radius is bigger, the final angle is smaller than the initial ones. So which factors affect springback? Yield stress, elastic modulus, thickness, and bend radius affect springback. Let's look at them step by step. Then I will explain why the springback is increasing or decreasing with respect to these effects. So let's check the engineering stress and strain diagram again. So we have steel with higher strength and steel with lower strength. Both has the same elastic modulus. So as we see that the steel with higher yield strength has more elastic recovery compared to the steel with lower yield strength. So yield stress affects the springback. How? As yield strength increases, so with the bigger yield stress, springback is more. So we observe more springback and we observe more elastic recovery. And let's check the elastic modulus. Again, with the engineering stress and engineering strain graph. Let's check steel with lower strength than aluminum. So both has the same yield strength, so or yield stress won't affect the results, because we need to look at the elastic modulus. So steel with a lower strength has a more elastic modulus compared to aluminum. So we see that the steel with lower strength will have less elastic recovery compared to aluminum. So what that means is that when we have less elastic modulus, we have more springback, or vice versa. More elastic modulus means less springback. And let's check thickness and bend radius. In order to check them, we can look at some examples. Let's consider bending a thin aluminum soda can and thick steel metal plates. So when bending the thin soda can, it's easier to deform elastically because the thickness is small and the springback effect is more noticeable. And the thin material retains some of its elastic energy and attempts to return to its original shape. But when we look at the thick steel plate, it involves much more plastic deformation due to the larger volume of the material that is being affected. And the plate has less relative springback because the permanent deformation dominates over the elastic deformation. So, as a result, soda can would have more springback compared to the thick metal plate. Let's check the bend radius. Let's compare bending a wire hanger, which is this one, which we use to hang our clothes, etc. And a pipe. Yeah, a wire hanger and a pipe. So when bending the wire hanger tightly, so we obtain small bend radius, the material undergoes significant plastic deformation near the bend area. And this minimizes springback because most of the deformation is permanent. In contrast, when bending a pipe with a large radius, the material is primarily elastically deformed. So this results in noticeable springback, and it requires corrections to obtain the desired shape. We see this in architectural fabrication actually. Curved beams with larger bend radius require more compensation for springback to ensure precise curvature, so we would not have any problems in architecture, in structural materials, let's say. So, how to eliminate springback? As we see, this is an important part of this effect. We can use some heat treatment, coining, or overbending. Overbending is basically bending it more so that when we observe springback, it would not affect us than desired. So this is an easy one. And heat treatments. Heating the material before or during bending can reduce its yield stress. So it makes plastic deformation more dominant and therefore reduces springback. So more dominant plastic deformation. In coining, a workpiece is subjected to a sufficiently high stress to obtain plastic flow on the surface of the material. So it is a cold working process. So basically, additional force to plastically deform the material would give us basically more plastic deformation and less springback. Finally, let's check the springback factor. Bend allowance is the same before and after bending, and this definition basically gives us this equation. And what is bend allowance? It is the length of the neutral axis in the bend area. So the length of the neutral axis in the bend area is same before and after bending. So what does it say us? Let's check if the springback factor is 1 and 0. If Ks is 1, that means there is no springback. How do we understand that? Let's check the final and initial bend angle. So if Ks is 1, that means alpha f is equal to alpha I. So that makes sense, right? The first and last situation, the initial and final angle is the same, so there's no springback. If Ks is 0, there's complete elastic recovery. What does it mean? Let's say alpha final is 0, so that means that there's complete elastic recovery. The final angle is 0, so our sheet metal is flat. Yeah, so there's complete elastic recovery. It's the same as before, so our bending gives us no solution. It's still flat. There's complete elastic recovery. Let's go back to this part. We said it has a critical role where the bend radius to thickness ratio is high. As we see in automotive body parts and structural members, I think I explained them. But in automotive body parts, the thickness affects it because when fabricating automotive parts, thicker panels generally experience less springback than thin body panels. So springback is still important. Yeah, thank you for listening. If you have any questions, I'd love to answer them. Have a good day.